Alright, let's solve this interesting LeetCode problem today on linked list, which is Palindrome Linked List. It says, given the head of a singly linked list, return true if it's a palindrome or false otherwise. And a palindrome is a sequence that reads the same forward and backward. For example, in this example 1, as you can see, we have 1, 2, 2, and 1. And if you traverse it from backward, it's also 1, 2, 2, and 1. So we return true because it's a palindrome. And for this one, we have 1 and then 2. If we go from backward, it's 2 and 1, making it not a palindrome. So on this whiteboard here, I have brought out our example 1. One easy approach to do this is to iterate through the linked list and add all the items into an array. So when we go like this, this is how the array will look. Then we can simply use 2 pointers. We place one here and place one here and keep shifting them, checking for where we meet values that are not matching. Then we can confirm it's not a palindrome. But the follow-up for this problem says if we can do it in linear time and constant space, which is where the trick is. If this were to be a doubly linked list now, you can use a pointer and shift it to the end of the list and keep one at the beginning. And while the 2 pointers have not met, you can increment the 1 from the beginning and keep on shifting the 1 from the end to the previous node, to point to the previous node. But this is a single linked list, so we can't do that. So the only way I could think about doing this was to reverse the end of the second part of the list. For example, since we are trying to keep a pointer here and another pointer here, now we check 1 and 1, they are the same, so we shift the both pointers. 2 and 2, they are the same. Now, what if we actually just have to reverse the second half of the list, making it 1 and 2. Then now we place 1 pointer here and 1 pointer here. And 1 pointer here. So now we check 1 and 1 are the same and we shift it. 2 and 2 are the same, which is pretty much in constant space and linear time. So the catch should be to find the middle of the linked list, reverse from the middle to the end, and then use 2 pointers as usual to check if it's a palindrome. So let's go and write the code. So the first thing I'm going to do is to find the middle of the linked list, which is we'll use our fast and slow pointer method. So we can do both of them will start at the head by default, and while fast and fast. What's next? I want to say slow. I'll just do it in one line. Now slow will point at the middle, so we can reverse from slow to the end. So we can do prev is equal to none, and let's say call is equal to, can do y call and call dot next. Why call? Sorry, why the current is not null? We can say we can get the next node, so we can later shift our current to it. So we equal to the current dot next, and then we can point our current dot next to be the previous, and then we can say our previous is equal to the current now, and our current is equal to the next node. Now after this, our previous will hold the values like this, which will be 1 and 2, which is reversed. So you can simply place y print is not null. You can check if head dot var is not equal to prev dot var. We want to return false. Aside that, we want to shift our head to the next node and also our previous, which is and then we can simply return true because it's a palindrome now. So now let's just run it and check if it works. Okay, so this approach fulfills this follow up which says linear time and constant space, and that's it for this video. See you guys on the next one.